So last time we were doing net ionic equations and we did some questions based on it, Anil. Questions based on net ionic equations. Okay, I'm sharing the presentation, the one which I was using last time. We did all these questions. These questions, we did them. We did 3 questions. I think we did this one, then this one, and this one. No, for which one? Aditi, you remember? Aditi, do you remember? Okay. Precipitation reaction. What about this one? We did that. Okay, this. Okay, fine. So I think children, today we have to practice questions on the precipitation reaction, which is a double displacement reaction. Okay. So today we are going to do practice on precipitation reaction. Do you have the solubility rules with you? All of you? This one? So it is not needed now because in the question they will give you the hint that what all is soluble. So they will give you the hint of that. Okay, let me see. I think it's still there. Yeah. Okay, still I'm giving you. And take out your polyatomic ion list. These two are needed. We did the practice of writing the net ionic equation that I remember. So now I'm starting with, we'll do the questions, children. But before that, before moving on the questions, let's do one more small topic. Okay. Do you have the list of strong acids and weak acids, which I think I told you earlier also? You have the list? If you don't have the list, so I provide you one here. I explained you how to check the strong acids and weak acids. Strong acids are strong electrolytes, weak acids are weak electrolytes. All these things we have done. So please download this list of strong and weak acids, strong bases and weak bases. Rule number 5 is also telling you about the strong bases. Okay, now let's start with acid-base neutralization reactions, and we'll try to understand the net ionic equations for these reactions. Open your strong acids and strong bases list. First, what is an acid? Acid is something which can give you H plus in water. So generally, acids are starting with hydrogen like HCl, HNO3, H2SO4, HClO4. All these are acids. Are they strong or weak? Check the list. Tell me. These acids which I have mentioned here, are they strong or weak? Check the list. HCN is also an acid. HC2H3O2, all these are acids. Now this one, the second category. The first category, if you check the list, they all are, yes, what are they? Anil? Strong acids. They are strong. Strong means, Lisa, 100% dissociated. They are completely dissociated. We discussed strong electrolytes, weak electrolytes. And Carbon containing acids are always weak acid. What's the meaning of weak acid? Weak acids are not fully dissociated, not 100% dissociated. So in the net ionic equations, if you remember, not 100%, not dissociated fully rather than writing 100%, not fully dissociated, very less dissociated, not fully dissociated. In net ionic equation, if you remember from your last class, I told you that strong electrolytes and strong bases or strong acids, they give you spectator ions because they are fully dissociated on either side. But if there is a weak acid, a weak base, and a weak electrolyte, which are not fully dissociated, not fully dissociated, you have to retain these weak acid, weak base, and weak electrolyte in case of your net ionic equation. So you have to see that, oh, this is a weak acid, take it as such. So understand this concept. So that's the reason I provided you with the list of strong and weak acids. Take a printout, is very strongly needed in unit 8 also. So let's start. I'm giving you an equation, a reaction of hydrochloric acid with NaOH. All these are acids and bases in water, aqueous. Now it's a kind of double displacement reaction, double displacement. Acid-base reaction is neutralization reaction, but it's also a double displacement reaction. Hydrogen of the HCl, which has a plus charge here, reacts with OH of the water, which is minus. Cl will go to Na plus. So double displacement. The product is a salt, NaCl, which is again soluble in water. Rule number 1 of the solubility rules. I provided the solubility rules in the chat. Those who have joined late, I don't know, you can see the chat message, all of you? The solubility rules. I can post it again. Here. Okay. So this is also rule number 1, completely soluble. Rule number 1, you have to practice and you have to memorize. Plus H2O, which is liquid. Now this is the complete molecular equation. Molecular equation. Can you give me the complete ionic equation? This is molecular equation. The ionic equation is ionic equation. For ionic equation, you have to see strong electrolytes, weak electrolytes, right? HCl, strong acid, weak acid. Check the list. I want answer from all of you. I want you to see in the list. Afan is strong. NaOH is a strong base or weak base? Check the list. Strong. NaCl, completely soluble, not soluble. Check the solubility rules. Rule number 1. Soluble. Strong electrolytes. Water is a weak electrolyte, strong electrolyte. Is it fully dissociated or not dissociated? Water. Water is very important. It's a weak electrolyte, children. It's not fully dissociated. Remember this thing. Okay? It's weak. Very good, Afan. Now we know everything about. And is this equation balanced? Yeah, it is balanced. Now we are going for ionic equation after having this knowledge that strong acid, strong base. Split this HCl into H plus aqueous, Cl minus aqueous, NaOH, because there is a strong base, Na plus aqueous, OH minus aqueous, right? On the product side, split this. Na plus aqueous, Cl minus aqueous, and water. Water you are going to retain as such. It's weak, so retain it. Don't split it. The one which are strong, they all are going to split as ions. They are fully dissociated. The one which is weak will be retained as such. Yeah, find the spectator ions, children. Help me fast. Spectator ions. So what are the spectator ions? Na plus and Cl minus. So now what is the net ionic equation? Net ionic reaction is H plus OH minus in giving you water. This H plus is in water. AQ, AQ. This is the net ionic equation. And for any strong acid, you take any strong acid with any strong base, the net ionic equation is always the same. Because they are fully dissociated, everything cancelled out, and you are left with H plus and OH minus. So let's see this. What I'm saying, is it correct or wrong? You heard this, children? You take any strong acid, any strong base. The net ionic reaction is this. Now we are checking it. Is it correct or wrong? Ready for checking? Give me one strong acid from the list. Anil, can you give me one strong acid, one strong base from the list? Thank you. Base. Anil. One base. So Anil has selected HNO3 as the strong acid, nitric acid, strong acid. And he has selected NaOH as the base. Complete the equation as double displacement, children. Double displacement. Can you give me the products? Double displacement. Na plus will go to NO3 minus. H plus will go to, yes, you are getting NaNO3. And this is soluble or not soluble? Check the solubility rules. Affine solubility rules which I gave you, soluble. So AQ means strong electrolyte. Plus water. Water is weak electrolyte. This is a strong electrolyte because it's a strong acid, nitric acid, strong acid. This is strong base. This is strong electrolyte because it's completely soluble. And this one is weak electrolyte. Write down the ionic equation. Complete ionic equation, children. Complete ionic equation or reaction. Strong electrolyte, fully dissociated, H plus, aqueous, NO3 minus, aqueous. If there is one hydrogen, it means this polyatomic ion has one minus. If you are unable to memorize it, you look at the formula. There is one hydrogen. One hydrogen means H plus, hydrogen is 1 plus. So nitrate is 1 minus. OH is 1 minus. And you know from the periodic table 1 plus. So please take care of the charges of the polyatomic ions in this particular unit. You should have your polyatomic ion list next to you. Can you see this completely dissociated? Completely dissociated. Strong acid, strong base. Giving you strong electrolyte, soluble. Yeah. See, Liza is giving us the complete equation. And Naisha, what should we do with this water? Should I split it or take it as such? It's a weak electrolyte. Take it as such. Don't split it. Now spectator ions. Yes, Naisha, good. Spectator ions. Cancel the spectator ions. NO3 minus, NO3 minus, Na plus, Na plus. What is the net ionic equation? H plus OH minus, giving you water. Exactly same we did with the other strong acid and other strong base. See, same equation. So this statement you have to take care. If you take any strong acid, any strong base, the net ionic equation is H plus plus OH minus, giving you water. You know, children, this reaction is exothermic. Heat is released here. Heat is released, exothermic. And for this delta H of reaction, delta H of this neutralization reaction is called as neutralization. You are neutralizing H plus and OH minus, giving you water. This delta H of neutralization for any strong acid and strong base is fixed. Is somewhere, I don't remember the exact value, somewhere around 57 kilojoules per mole. That's the experimental proof that all strong acids and strong bases, they have exactly same net ionic equation. Means this is the only reaction there, only reaction, nothing else is happening, right? Any questions from this strong acid and strong bases net ionic equation? Now, let's do some questions based on it. Here. So children, please, all of you, try to answer the questions. I'm going to create some space so that we can work nicely. So when an acid reacts with the base, acid reacting with the base, and the base is metal hydroxide, sodium hydroxide. These are metal hydroxides, all these metal hydroxides. Metal hydroxide, then children, product is salt and water. So some students, they are very confused with the word salt. What do you mean by salt? Salt is, yes, any one of you? An ionic compound. Ionic compound. And what's an ionic compound? That we know. Metal with non-metal. So in salts, we have a metal, right? With not only NaCl, Aditi, Lisa, it's not only NaCl. Any metal with non-metal, like aluminum nitrate, aluminum sulfate, sodium sulfate, anything which has metal with non-metal. That non-metal can be, that non-metal can be a polyatomic ion. I think Liza and Aditi are talking about the table salt. Table salt, eating salt. So when I said salt, they have typed NaCl. Actually, that is table salt, NaCl. It's a salt, but it's eating salt, table salt, right? Okay. It's a mixture of many things. It's not pure. So we are good with the meaning of salt? Okay. Now you're going to check the list of strong acids and strong bases. Open it. Tell me, look at this A. Look at this perchloric acid. Perchloric acid. Strong acid, weak acid. Yeah. Strong electrolyte, weak electrolyte. Means fully dissociated or not dissociated. You say strong electrolyte. Ariba, you have the list with you. So why you're not answering? Afan, I want all of you to look into the list. Aslisha, Naisha. Okay, Aslisha, you leave and rejoin the class. Strong electrolyte. You have the list, right? Now check this MgOH twice. Is it a strong base or weak base? And it's already written here solid. Solid means, check solid is written here. Solid means not fully soluble, slightly soluble. It's weak base. So if solid is written, then it means it's not a strong electrolyte. It's not fully dissociated. Some part is dissociated, but other is as such. Now, do the double displacement. Take care of the charges. What's the charge on a hydrogen? 1 plus, we know that, right? So perchlorate is, check how many hydrogens here? 1. So minus 1. What is the charge on magnesium? That you know from the periodic table. Magnesium. Yes, 2 plus. And OH, because with each magnesium there are 2 OH hydroxide. 1 minus. That you should know. Afan, is it okay? Now do the double displacement. H plus will go to OH minus and perchlorate will go to magnesium. Okay. Check your speakers, Ashlisha. Speakers. Your speakers may not be working. Sumi is troubling with this new update. I've seen many children, they have this problem of no, they cannot hear me initially. So you have to check your speakers. Go and test your speakers. Now, this is a weak electrolyte. Weak electrolyte. Now do the double displacement. So H plus is going to OH minus to give water. So one of the product is water and the other product is, and always remember metal will come first. So magnesium will come first and chlorate. Take care of the charges and make the right formula. This is the formula, right? No problem with the formula, Afan? Okay, now this is the equation. Now the second is balance the equation. Is it balanced? We call this equation as molecular equation. Now check whether it is balanced or not balanced. Balance the equation, children. It's not balanced. So what should I do, Anil? See, 2 chlorates, right? So put 2 here, 2 in front. Now chlorates are balanced. Check your hydrogens. 2 here and 2 here, 4. But on the other side only 2. Put 2 here. Is the equation balanced now? It's perfectly balanced. Any questions, Ariba? Now, this magnesium perchlorate, if you remember, you check the rule number 1, all perchlorates are soluble. It's a strong electrolyte. Strong electrolyte. For strong electrolyte, I'm writing Se. For weak electrolyte, I will be writing Ve. Right? So it's a strong electrolyte. It's fully dissociated, completely soluble. But water is a weak electrolyte. Water is not going to dissociate completely. Now this is molecular equation. Now let's write on the complete ionic equation. Complete ionic. Strong electrolytes are fully dissociated. 2HClO4, fully dissociated. So what are you going to get, Aditi? 2H plus aqueous, 2ClO4 minus, 2 is in front, so that's why 2, 2. Aqueous. This is a weak electrolyte, so what should I do? Take it as such. It's not going to dissociate completely. But this is a strong electrolyte, this one. What should I do? Split it completely into ions. Mg2 plus, plus, this is 2 here. So 2ClO4 minus aqueous. They all are in water. This is a weak electrolyte. What should I do, Naisha? Water is a weak electrolyte. Take it as such. Yeah, don't split it. Good. Now find the spectator ions, Naisha. Spectator means the one which are seen as such without any change. They are as such on the reactant side and the product side. So please identify spectator ions. And remember, spectator ions are always coming from strong electrolytes, strong bases, strong acids. And that is perchlorate, which has come from strong acid, which is a strong electrolyte. That's it. So spectator ion is ClO4 minus. Now give me the net ionic equation. Net ionic reaction. Now this time, this reaction is between a strong acid and weak base. So a strong acid with weak base is going to be different, right? Because the weak base we are retaining as such. So net ionic equation is the strong acid is giving you H plus. Perchlorate is the spectator. But the weak base is as such, see, because it's not fully dissociated. It's a weak electrolyte, giving you Mg2 plus, aqueous, and 2 water molecules. See the net ionic equation for weak acid with strong base or with strong acid with weak base will be different. Different from strong acids and strong base net ionic equation. So can all of you type the strong acid with strong base net ionic reaction? Please type it here. What was the net ionic reaction of a strong acid with strong base? Mhm. What was it, Anil? What about rest of you, Afan? Remember I was explaining you on the whiteboard that net ionic equation for any strong acid with any strong base is going to be same. So please type it. Very good, Ariba. Naisha, try to type it. Hurry up, children. I'm waiting for the answer. Afan, Liza, good. So remember this. So this one is a strong acid and strong base. Its net ionic equation will be this. This is a strong acid and strong base. Net ionic equation will be this. Right? And what is that? H plus plus OH minus giving you H2O. Because the base will give you only OH minus, calcium 2 plus will become spectator. And HCl will give you H plus and Cl minus will become spectator. Okay. Now, can we work one more equation? Let's pick up this one, B. Identify the acid as strong acid or weak acid. Open your list. Check the rules. It's a carbon containing acid. If it is a carbon containing acid, then all carbon containing acids are, yeah, what is the rule? They all are weak. So this carbon containing acid, this one is a weak acid. So I'm writing here HC2H3O2 aqueous. It's a weak acid. KOH. Only Anil is answering. You don't have your list open in front of you, Afan? KOH. Is it a strong base or weak base? Check, Afan. First group hydroxides. First group. K is in the first group. Potassium. First group hydroxides are strong bases. Anil, strong bases. It's a strong base. KOH. First group hydroxides are strong bases. This is strong base. I'm writing Sp. So strong base is a strong electrolyte, fully dissociated. Weak acid is a weak electrolyte. Take care of the charges. What's the charge on this hydrogen here? Yes, any one of you? What's the charge? Liza? Yes, very good. So what's the charge on this acetate? Very good, Naisha. -1. What's the charge on K? Look at the periodic table. Very good, Aditi. What's the charge and then OH? -1. Do this thing first before you complete the equation. Because many children, they don't check the charges and then they write the wrong formulas. First, you check the charges on the ions. It's a very compulsory step. And then you do the double displacement. Now, K plus will go to acetate. So you're getting KC2H3O2. And H plus will go to OH minus. And you're getting H2O. Now check the solubility rules. Check the solubility rules. Aslisha, you can hear me now? Solubility rule for this. First rule. Okay, that's good. First rule is soluble. Soluble means, Anil, is a strong electrolyte. It's completely soluble in water. So write AQ next to it. Water. Now all of you please try to answer. Water is a strong electrolyte or weak electrolyte? Not only Anil, all of you. Weak electrolyte. The weak electrolytes or weak acids or weak bases, we are going to take it as such. They are not going to split. They will split, but in very less amount. So what is the complete ionic equation? Complete ionic reaction. So right now what we are doing, children? We are doing how to write net ionic reactions for acids and bases. Yes, Anil is reminding us, check whether the equation is balanced, molecular equation. Before you proceed for the complete ionic equation, please check whether your molecular equation is balanced or not. That's very important. Anil, thank you very much. Is it balanced? It is balanced. Okay. But this should be always you have to speak this. Okay, this is the molecular equation. Let me check if it is balanced or not. And then you go to the next step. So the next step is weak acid. What should I do, Naisha, with weak acid? Shall I take it as such or split it? I'm going to take it as such. No splitting. It's a weak electrolyte, but it's soluble. See AQ. It's a weak electrolyte, but soluble in water. Naisha, do not split. It's a weak electrolyte, Naisha. Strong base. What should I do with the strong base? Split it. It's a strong electrolyte. Split it into ions. That is the reason I told you check the charges of all the ions to make the right formula, to write the right complete ionic equation. There you have to show the ions. And this one is a strong electrolyte. This one is a salt. It's a salt of potassium with acetate. Potassium acetate. It's a salt and is soluble. You see, AQ. So what is it? You will split it into ions like this. It's a strong electrolyte because it's soluble. Rule number one, soluble. What should I do with the water, which is a weak electrolyte? Take it as such. Do not split into ions, right? Okay, now please focus this complete ionic equation and give me the spectator ions. Spectator. So please check what are the spectator ions. Spectator means the one which are not undergoing any change during the reaction. No change, yeah. They are not participating in reaction. They are helping in neutralizing the solution only. So they have to be there. Yes, Aslisha, you have to answer in general chat. She's right. She's saying K plus and that's it. Not acetate. See, acetate. Do you have acetate on the other side? So no acetate. Only K plus. You're getting it, children? Because acetate, this minus, we don't have here. It's an acid. So what's the net ionic equation? Net ionic reaction. The weak acid will be as such. Yes. When you are answering something, what I'm asking, then always answer it journal chat. Only when you are just giving me the final answer, that you can put it in direct message. But if I'm asking this question and you're answering it, put it in journal chat. Let others see what you have written. Plus H2O. So are you getting the difference between a strong acid, strong base, net ionic equation, and if there is a weak acid or a weak base, then the net ionic equation is different. Weak acids and weak bases, you are going to retain them as such. You're not going to split them into ions. And water is already weak electrolyte. So practice it. We are good with this? Okay, now children, do you have the list of strong acids and strong bases with you, which you have to practice? And by practicing, you can memorize it. Do you have? Say yes or no, all of you. Is it open in front of you? Okay, good. If it is open in front of you, can you answer this question? Question 68 here. This is children's Zumdal book. I have already uploaded there. So generally, I'm doing questions from this book. It's a very good book, very nice book, and AP type book. It's not exactly AP because many things we need not to do. So I'm very selective in doing the questions. But it's really good book. If you want to choose a book for your general chemistry and then MCAT chemistry, then this is the best book. 68. What acid, what base you should use to make this salt? I want to make this salt. So what's the formula of the salt? What is the formula of the salt? Potassium is K plus. Perchlorate is ClO4 minus. So the formula is KClO4. So can you tell me from where I should get this K plus? What K plus is a metal ion and bases, they have metal ion with the hydroxide. So this K plus will help you in deciding the base. So what is the base I need here? Any one of you? KOH, isn't it? And perchlorate, this anion, this metal ions, they come from base and perchlorate has come from acid. It has one minus, so it is perchloric acid. You have the list already with you. You can identify. And this will give you KClO4. Liza, you have that list of polyatomic ions with you? Do you have that list? No? No, no. I'm talking about new students. Do they have the list of polyatomic ions? So I'm giving you the list again. Okay. So perchlorate is ClO4 minus. The way I did this question, A part, can we do the B part? Check cesium. Look at the periodic table. Tell me, what is the charge on cesium? CS. Yes, please answer it. +1. It is in first family. Nitrate. Check your polyatomic ion list for nitrogen. NO3, 1 minus. So the compound is the salt. These are salts, right? The salt is cesium nitrate. So this cesium plus will come from acid or base? Cesium plus will come from, it's a metal ion. It will come from base. And this nitrate will come from acid. Now, can you tell me what is the base needed here? Give the formula of the base. Yes, Nivriti, formula of the base. Metal hydroxide. Cesium hydroxide. Very good. And what's the formula of the acid? Check the list of polyatomic ions. Nitric acid. And that will give you, oh, I missed one of the product here on the top equation here. What is the product I'm missing here? Any one of you? Here. One thing is missing, water. Thank you very much. So same here, you will get cesium nitrate and H2O. Okay, now next question. Is this cesium hydroxide a strong base or weak base? Check the rules. First group hydroxides are always strong bases, so it's a strong base. This HNO3, is it a strong acid, weak acid? There are hardly 6-7 acids which you have to practice. It's a strong acid. So what can be the net ionic equation for this reaction? Net ionic equation. They are strong acids, strong bases. They are going to split completely. You have spectator ions, they will cancel out, and you have only ions of the water, H2O, H plus and OH minus. Okay, good. Can you check this equation? KOH, strong as base or weak base? Try to answer, all of you, please. It's a strong base. Why? Because it's a first group hydroxide. Perchloric acid, strong acid, weak acid. Base is strong acid. So what can be the net ionic equation? What can be the net ionic equation? This. Same. Yeah, same as earlier. Means this one is also strong base, strong acid. This is also strong base, strong acid. So the net ionic equation is going to be the same. But if any one of them is weak, then it will change. If there is a weak acid, you have to take it as such. If there is a weak base, you have to take it as such with water. Water is also weak, right? So that's a story about the neutralization reaction and how to write down their equations, everything. Now we are going to do some questions based on it. Calculation questions. When you add an acid into base, that results in neutralization reaction. So we are going to do some simple questions based on that. Everybody knows the meaning of the molarity? Molarity. Molarity is moles per liter. Can you give me the other definition? Other definition of molarity? Two definitions are there. Molarity is defined as moles per liter. But molarity is also defined as millimoles per milliliter. This is the other definition. They will give you the same value because you multiply mole by 1000. It will become millimole. You multiply liter by 1000. It will become milliliter. 1000 cancelled. Answer will be the same, right? And we will be working with millimoles also. So that will simplify your calculations. Are we okay with these two definitions? And what's the meaning of molarity? Meaning, which Aditi is typing here in the direct message. Meaning is concentration. How to represent molarity? How to represent? Like for example, you want to say that HCl molarity. How many molar is the solution? Concentration of HCl. If some teacher is saying, okay, concentration of HCl, then you are going to put square brackets around HCl. This means molarity. Yes, Anil Nivriti, thank you very much. So please take care of these things, very important. Now, let's see question 69. So here we are doing a reaction of HCl with NaOH, A part. So when you are doing a reaction, acid-base reaction, we need a very special equipment for that. We call it as titration. Titration. We need a burette. We need a conical flask. Burette is it's a kind of instrument which helps in measuring the volume. There are marks on it like this, right? You need a stand to hold the burette. This is the stand holding the burette here. There's a knob here. So the stand is holding the burette, and there is a opening, like to control the flow of the liquid. There is a stopcock here. You can open it. When you open it, the liquid will start coming out. You can close it. You can measure the volume from the marks over here. So you can take base into this and acid into it. And then you can start adding base into acid. A reaction will start. And because these are volumes, here also you know the volume of the acid you are using in this conical flask. You know the volume of the acid. So you know the volumes, you know the concentration. So generally titrations are dealing with molarity and volumes. Molarity and volumes. So most of the questions which you see of the acid base, they are in terms of molarity and volumes. Check here. What volume of the following acids, these acids, will react completely with this much NaOH? Again, volume and molarity, right? What is so special about molarity and volume? Let's go back to this equation, Naisha, above equation here. What is molarity? Moles over volume in liters. So what is moles then? Moles are molarity times volume. Make it a habit of using it directly. Yeah, Lisa, yes, please. And what is millimoles? Millimoles. What is millimoles? Molarity times volume in milliliter. See this equation. So I want you to practice these two equations. It's going to help us in Unit 8 also. This is just a rearranged form of your molarity equation. It's a very popular application, which we are going to use here also. Let's do A part. So hydrochloric acid reacting with NaOH, everything is happening in water, acid bases in water, giving you NaCl and what's the other product? Yes, children. What's the other product here? Water, Afan, be faster than Anil. Okay. This is strong acid, strong base reaction. So what do you know? What do you know? Molarity and volume of NaOH. This is in ml, right? So do you know the millimoles of NaOH? How much is that? 10 millimoles? 10, right? Multiply this. M times V. Yes, Afan. Good. 10, right? Very good, Afan. Now NaOH is information is there. But look at the equation. What do you think? How many millimoles of HCl needed to neutralize this 10 millimoles of NaOH? Isn't it 1 is to 1? 1 is needed to neutralize 1. Balanced equation. So can I say the millimoles of HCl needed here is also 10? Because they are reacting 1 is to 1. If I say this is the molarity times volume of NaOH, which you can assume as M1, V1, but these millimoles are also equal to molarity times volume of HCl. Can I say that, children? What does it mean? That I can use this equation because what is the aim? Aim is the volume. So I know that the millimoles of NaOH and the millimoles of HCl are same, 1 is to 1. So I can say that M1V1 of NaOH of the base is equal to M2V2 of HCl. No, 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 no. This is not dilution law. I'm not doing dilution here, Anil. But yes, it was the dilution law earlier. But now it is, I'm using it on a reaction. Dilution is not a reaction. What is dilution, children? What is dilution? Dilution is adding water. When you add water, moles are not changing. So you can use M1V1 equals to M2V2. So during dilution, moles are not changing, moles of the substance. Like for example, you're doing dilution of this HCl, means you are adding water. So moles of HCl will not change. Only concentration will change, volume will change, molarity will change, but moles will not change. But here, I'm not adding water. I am doing a chemical reaction, right? So I'm using this method. You can solve it. What do you want to calculate, children? I don't know whether the question is clear to you. Is the question clear? What do you want to calculate? What are you looking up? What's the question? Can you tell me what are we calculating? Mhm. Are we calculating M1, V1, M2, V2? Which one we are calculating? V2, yes. Rearrange the equation, Naisha. M1, V1 over M2. M1 is given for the base 0.200, V1 50.0. There is no need of converting that into liters. Take it in ml divided by M2 because it's a ratio of the volumes, right? So divided by M2, M2 is 0.100. Answer is mhm. What's the answer? How many sig figs? 3. This number has 3. This number has 3. Put a decimal. 100 point. No, no zero, no zero. 100 with decimal. Aditi, is there any decimal in your number? No. If you write 100 ml, then it means 1 sig fig. These zeros are not counted. But if you write 100 with decimal, then it has 3 sig fig. Trailing zeros are counted if there is a decimal. Yes, Anil, good. But are we okay with this M1 V1 equals to M2 V2? But is there any other way? Is there any other way for calculating volume? Yes, there is. I'm going to show you the other way. Rather than using M1 V1, we can use another method and you will come to know the reason why I'm giving you the second method also. Now, what do you know? Do you know the millimoles of NaOH used? Millimoles of NaOH? Molarity times volume of NaOH, which you gave me earlier as 10.0. You remember Afan gave the answer first. Millimoles of NaOH. And from here, we know that the equation is 1 is to 1. So I know the millimoles of HCl also. How many millimoles of HCl? Same, 1 is to 1. I know the molarity of HCl. What's the molarity given? 0.100 molar. I want to know the volume. I can use this equation, this one. So molarity is millimoles, that is 10.0 millimoles divided by volume, which I don't know. I want to calculate. Molarity I know. How much is this? 0.100 is 10.0 divided by V. Calculate the V and V will have the same units as that of the because these are millimoles divided by milliliter. So this volume will be of milliliter. In the equation, I'm using millimoles over milliliter. If you do this calculation, take V on the other side, 0.1 here, you'll get the same exact same answer, 100 decimal, 3 sig fig ml. Which method would you like to use? Which one is better? Anil is saying second. What about you, children? Oh my God. But do you know the second method is not valid on all equations? Second method is valid only if it is 1 is to 1. If it is not 1 is to 1, like here, this is 1 is to 1. So millimoles of this equal to millimoles of this. But do you think all reactions are 1 is to 1? No. So that is the reason second method is dicey. If you try to use the second method on some equation where, like for example, this one, you cannot use it. But I have a solution for that. If you are liking second method, use it, no problem. But what you have to do, you have to take care of the coefficients. So I'm going to give you one equation here. Write it down in your notebook because you are more happy with the second method. So use it like this. Let's say this is M1 V1 for the base. You divide this by the coefficient N1. Okay, Aditi, no problem. M1 V1 base, we divide by the coefficient N1, right? Which is equal to M2 V2 divided by the coefficient N2. So what is N1? N1 is, okay, Liza, now you start asking question if something is not clear. You missed a very important part. N1 is number of moles of the base in the balanced equation. N2 is number of moles of the acid in the balanced equation. If you use this equation, you will never be wrong. Like here, in this question, what are the moles of HCl? What is N2? 1. This is 1, right? What is N1? Base 1. So your equation is M1 V1 equals to M2 V2, no error. So this is the safest way of using this equation on chemical reactions. Chemical reactions. So what I was trying to say that you cannot simply use M1 V1 equals to M2 V2 on all reactions. No, you have to check the coefficients. Only then you can use. Ready for a question now? Okay. I'm going to erase this. Sorry. Check this one and this one. So first you write on the equation. HCl is the acid. Strontium hydroxide is the base. It's a strong base, children. Fully dissociated. Giving you, take care of the charges and give me the right formulas. Yes, strontium is in second group. So the product is, help me with the product. Strontium chloride, which is SrCl2, is completely soluble, strong electrolyte, plus water. Naisha, any confusion with the equation? Now you balance the equation. Balance the equation. Naisha, how many chlorines? Two here. How many here? One. So put two. Check hydrogens. Four here, two here. So put two. Yes. Okay. Now in this equation, the coefficients are not 1:1. So you can use this equation. M1 V1 over N1 equals to M2 V2 over N2. Or you can get the moles of the acid. See, moles of the acid are given, millimoles. Convert them into millimoles of strontium hydroxide. Use the molarity equation and calculate the volume. Like, let's say this is acid. You can use anyone anywhere. Like, I'm taking this as acid, this as the base. Plug in the values. What is M1? 0.2? 0.200 molar, right? What is V1? 25.00 ml. In M1 V1 equations, there is no need of converting milliliter to liter. You have to just ensure that in both the cases, V1 and V2, they should have the same units. That's it. So I'm taking milliliter. N1, what is N1? 2. This is 2. Get this value, children. And that will be M1 V1 over N1. Is it 2.5? This value, which is equal to M2. What is M2? It's given here. 0.05. V2, you want to calculate. That's the question. N2, 1. See 1. Now rearrange the equation and get the V2. V2 is 2.5 divided by 0.05. Units milliliter. Why? Because I'm using 25 ml. And this answer will be 50. How many sig figs? 3. So 50.0 ml. Very good, Aditi and Anil. Afan, where are you? Here. Okay, good. So keep answering. Ariba, where are you? Nivriti, Aslisha. Please ask questions if something is not clear. During this question, Aditi and Anil were interacting. Rest, all of you were not interacting. So I hope everything is clear. Can we use the second method now? Let's see the second method, okay? Because you said that you like this method. Not all questions, only the questions which are related to, Anil is asking, shall we practice all the questions? If you are targeting very big later on general chemistry and you have plenty of time, then practice as many as you can. But for AP, only selected portions are there. You have to see that, okay, this is the part of AP chemistry. Practice only that much part. And Zumdel is very much organized. They have written the title of the topic and then questions. So just check the title of the topic, acid-base reaction, AP part. Practice it. The title which is not the part of AP exam, you can leave it. There are many chapters which are not the part of AP exam in Zumdel book. Many chapters, many. Okay, so ready for another question, but I want you to do the second method also here. What you do, get the millimoles of HCl. Convert the millimoles of HCl to millimoles of strontium hydroxide. Then use the equation molarity as millimoles divided by volume in milliliter. And they are asking volume. So volume in milliliter will be millimoles. Rearrange the equation. over molarity. See, you can use this also. Generally, everybody is using this, children. This, not this. This is easier. How many millimoles of HCl are there? 2.5. So, millimoles of HCl are 25.00 ml times molarity, m times V. That's the millimoles of HCl. Plug in the ratio, molar ratio from the balanced equation. That 1 millimole of strontium hydroxide divided by 2 millimoles of HCl. Stop here. Millimoles of HCl cancelled, and you will get 2.5 divided by 2. That is, I think, 1.25 millimoles of strontium hydroxide, isn't it? Plug in that value here. 1.25 here divided by molarity. Molarity is 0.0500. What's the answer in milliliter? Can you check it? Are we getting the same answer? Earlier you said 50 ml, right? Is it also 50? Or we have done some error? Can you check this, children? Oh, this is not 2.5. Sorry. This is 5. 5.0. Here, this answer is 5.0. 25 times 0.2, 5.0. So this is 2.5. So here it is 2.5. When you work out this answer is 50 ml. 3 significant figures. We are okay? So it's up to you. You can use this also, but this equation will not be mentioned in the exam. Dilution law will be given to you, M1V1 equals to M2V2. But remember, you cannot use it on every reaction. For reaction, you have to have this N1 and N2 also. So you children are not interested in this one? I prefer this one. AP also prefers this one. Moving on. Let's do one more question. Now this question is very different, very important, very different. So today I'm doing acid bases neutralization reactions and the questions based on that. The type of the reaction is acid bases. We were doing precipitation and Anil told me that we did some questions. So I'll check how many we have done and we'll do more questions based on that in the next class. Okay, 71. This question is based on limiting reactant. You have done the limiting reactant with me? Have you done the limiting reactant with me? Yes, children. All of you know the meaning of the limiting reactant? Yes or no? Okay, good. So let's do a question based on limiting reactant. So first thing is that how did you know this question is limiting reactant? How can you say this is a limiting reactant question just by looking at the question? In this question, if you see, the reactant is hydrochloric acid, HCl, and its amount is given. Moles are given. Molarity times volume, because it is in milliliter. So millimoles are given. Millimoles are given, right? The second reactant is BaOH twice. And the millimoles of BaOH twice, the amount of BaOH twice is also given. So when the amounts of both the reactants are given, then the question is a limiting reactant question. You don't know which amount is more, which amount is less. So you have to check, because here HCl is given, BaOH twice is given. So one of them is in excess, one is limiting. Complete the equation. Can you help me in completing the equation? Hydrogen is plus, Cl is minus, Ba is 2 plus, OH is minus. Now do the double displacement. BaCl2 plus H2O. This is aqueous. Balance the equation. 2HCl. Now you cannot use M1V1 equals to M2V2, right? Because this ratio is not 1:1. Okay. So is the equation balanced? Now it is balanced. Now the question is, what is the concentration of H plus or OH minus? If HCl is the limiting reactant, then OH minus is in excess. If BaOH twice is the limiting reactant, then H plus is in the excess. So I need to know what is needed. Know your limiting reactant. Which one is the limiting reactant? So let's try. This is the reaction. Can you tell me what are the initial millimoles here of HCl? Initial millimoles of HCl. So millimoles of HCl are molarity times volume. And Anil is saying is 18.75 millimoles. So I'm writing here 18.75. Can you work out the millimoles of BaOH twice? BaOH twice. Again, molarity times volume. So that is 0.0550 times 250. And Anil is saying 12.375. I think he's right. We are okay with this calculation? I'm going to plug in these millimoles here. 12.375. This is 18.75. This is 12.375. Initially, before the reaction, before you added these two, what is the amount of BaCl2? Before we added these two, what is the amount? 0. Water. Water from the reaction is also 0, right? Water from the reaction is 0 because reaction has not started. Initial. I means initial. Reaction has not started, right? Now, final. So now to know the limiting reactant, you convert your reactant HCl amount into reactant BaOH twice. You can pick up anything, like you can start with reactant BaOH twice and convert that into HCl. This is how we work out the limiting reactant, or you can convert them into the product. So whatever way is okay. This is one method. Second method, that you take reactant, R means reactant. You take reactant HCl, convert that into product BaCl2. You take reactant BaOH twice and convert that into product BaCl2. Whoever is giving you minimum amount is the limiting reactant. So these are two ways of knowing the limiting reactant. Which one would you like to use here, children? The first or second? Let's use the first one. Can you tell me 18.75 millimoles of HCl? 18.75 millimoles of HCl will give you how many millimoles of, will react, not give, sorry, will react. How many millimoles of BaOH twice? Plug in the ratio from the balance equation. 1 millimole of BaOH twice over 2 millimoles of HCl. I can read the equation in millimoles, right? 2:1. So how many? 9.37. I'm not using calculator, so please check it. 9.375, yeah, millimoles of BaOH twice. How many are given to you, Naisha? How many millimoles of BaOH twice are given to you? So is BaOH twice, what is needed is this. Needed is this. Given is this. So who is the limiting reactant then? HCl? Because BaOH twice will be left unreacted. Because it is given in excess. It is excess. This is, we need only this much for the reaction. But given to me is 12.375. So BaOH twice is in excess. Right? Right now we are trying to understand limiting reactants. Those who are weak in limiting reactants, please keep asking questions here. Now let's see. Whoever is the limiting reactant will become zero after the reaction. It will it will not be present after the reaction. Means this HCl is zero. It runs out first, you can say. But rather than using that language, I prefer to say that limiting reactant will not be there in the solution. It's zero. It's not there. And reaction has stopped. The reaction has stopped because limiting reactant is zero. That's why it is stopped. I need both the reactants for the reaction. If HCl is zero, reaction stops. And BaOH is still left, not reacted completely. How much is left? So BaOH twice left, because it's the excess reagent, is 9.375, oh sorry, 12.375, the total amount, minus 9.375, which Anil is already saying that 3 millimoles. So that is left, finally, after, you can say after or final, after reaction or final. Initial means before reaction. So 3 millimoles. Is it okay? Now, can you complete this part, children? How much BaCl2 formed? How much? No. You see, this ratio is 2:1, and this is 1:1. Whatever BaOH twice has reacted, that is the millimoles of BaCl2 formed. It is 9.375. You can use your limiting reactant for the calculation. 18.75 millimoles of HCl. Plug in the ratio from balanced equation. 1 millimole of BaCl2 divided by 2 millimoles of HCl. You're okay with this molar ratio? Cancelled. You'll get the same answer. 9.375 millimoles. Never do any calculation with the excess or the amount of the excess left. Don't touch them. They will give you wrong answers. So excess reactant should not be touched in your calculation part because it's not going to react completely. All the calculations should be done, must be done using the limiting reactant. You can call it as king of the reaction. Limiting reactant is the king of the calculations, right? Never use excess reactant. Am I teaching Anil only? Children, this is a tough topic, limiting reactant and all these things. It's tough. If you want me to repeat it, I'll repeat it very nicely again in the next class. Do you want me to repeat it, Afan, in the next class? Not with this question. I'll teach you limiting reactants separately. Afan, Ariba, Aslisha, Laisa, Naisha, Nivriti. Do you want me to do it again? It's a very important topic. It's a very, very important topic, children, limiting reactant. So I will cover it again because with this acid-base neutralization, the question, and I'm starting teaching with this limiting reactant, maybe few of you are confused. Nivriti, is it okay? Nivriti. Oh, okay. What does it mean, Anil? Okay, my saying is this, that if you want to learn chemistry, follow the rules and concepts. You see that I'm giving you plenty of rules. Like today I was teaching some student and I said, okay, these are the oxidation number rules. And she said, our teacher didn't give us any rule. I said, if you follow these rules, life will be very comfortable with oxidation number rules, which you're also going to do. You see, I'm giving you solubility rules. I'm giving you that list of the acid base polyatomic ions. So they help us in moving faster. Concepts are important, very important. So same I'm going to do with the limiting reactant. I'll explain you again more in detail. But we are done with this question, children, this question. So which one is in excess? BaO is twice. So whose concentration is more? H plus or OH minus? OH minus. Because H plus is 0, see? How much it is more? You see BaO is twice. One more minute, children. I know time is up. One more minute to complete the question. BaO is twice is going to split as Ba plus 2 plus and 2OH minus like this. What is this BaOH twice? How much was that? 3 millimole. 3. The left. The one which is left. 3 millimole. So 3 millimole will give you how many OH minus, children? 6 millimoles. But the question is not asking millimoles. It's asking the concentration of OH minus. That is millimoles divided by volume in milliliter. Which volume? You are adding these two, 75 with 225. Add them. You're mixing the solutions. You're doing titration, mixing them. So millimoles is 6. Volume is 300 milliliter. Millimoles divided by milliliter is molarity. So how much is this? That will be the answer. 0.02 molar. That's the concentration of OH minus in the final solution. These questions are very, very important. But before these questions, we'll practice limiting reactant again. Okay. See you in the next class. If you have any questions, you can stay back. See you then. Bye. Bye bye. Nivriti, you have any question? I cannot hear you. Can you type it here? Nivriti, type your question because you are not audible. Your audio is not working.